Welcome all. I'm Ornisha Dan, a member of the GNU Linux Users Group NIT Durgapur, and here we are with yet another roadmap video. For many of you, it's the end of your first year in college, it's summer break, and you want to explore new stuff. You want to utilize this time to expand your skill sets and your knowledge. Every day you chance upon some new domain that interests you and intrigues you, and it's very easy to get lost in the world of YouTube videos and tutorials and articles as you try to find your niche. And that's where we step in. In this video, we try to go over all of the roads that you might be interested in, and we try to give you the first push you need to get started. So let's look at some of the domains we're going to focus on in this video: software development, app development, competitive programming, research internships, and last but not the least, we have something for our cybersecurity enthusiasts as well. So stay tuned if you're interested in any of these or would want to know more about what exactly these domains entail.
Competitive coding is one of the paths where a student can explore during his or summer. So let's talk about what is competitive coding. So competitive coding is a mind sport for solving a data coding problem using data structure and algorithm, but with the restriction that you have to solve the problem within a stipulated time, and the solution has to be most efficient one in the term of space and memory. So next thing is how to start with C. First thing is you have to master the basics of one language you are comfortable with. It can be anything: C++, Java, and Python. C++ is the most used language because it's a faster execution time and rich standard template library which provide us with various data structures like sets, maps, and other data structures. Next, it is also important to learn about the space complexity and time complexity, and how to calculate the space and time complexity of a given program. Now, next step is to learn the fundamental data structures and algorithms, for example arrays, stacks, queues, and arrays, and also some basic problems on each of them. Now, some of the students might find CP a difficult task for them, so they can start with DSA, that is a bit different than CP, and it is enough for them, enough to crack the coding route of the company for internships and placement, as DSA is a bit easy as compared to CP and does not require much logical thinking and mechanical skills as compared to CP. So let's talk about and how to practice CP. CodeChef Long Challenge is good for beginners in CP. It is a 10-day long contest and given 10 problems to solve, and so you can think of develop logical problem solving skills during these 10 days and code 10 problems. While lead code is good for DSA practice, and HackerHack has a specific CP section called code mode. You can learn various data structures and algorithms and practice problems from there. While if you want to perform well in the coding contests like Hacker Cup by Facebook, CodeJam by Google, and ICPC, so you can definitely practice with the code forces, Div 2, and get Div 2 questions. While if you're a beginner, it started with Div 3 and then slightly move to Div 2 once you start increasing. And it's very important to solve the problems after the contest is over. With this, that would help you to identify your mistakes during the contest. Thank you.
So the next part is web development, how and what to start. So the most basic part and the most confusing part is how and where to get started. We all face this problem, and now let's keep it simple and explain to you how to get started. First of all is to find your interest, whether you like backend or whether you like front end. This is totally up to you. Uh, if you are sure that you like backend, then start learning languages like Python or JavaScript first. If it is front end, then start with HTML and CSS. Just start with HTML and CSS and learn JavaScript along with it. The point here is to not waste your time pondering about what you like and what you don't. Just start with basic HTML, CSS, JavaScript, and you'll lead your way. You will lead your own way, whether you like the front end part or the back end part. Now coming to the backend part. First I'll explain the backend part. So to make a dynamic application, you need to know a backend framework. This is very simple. So what do you start with? First of all the mentioned frameworks here are have their own pros and cons. They are the best for what they are used for, and all of them are popular in demand. So you can choose any one of them and start learning. If you are familiar with Python and worked with Python before, then Django and Flask would be easier for you to learn and use. If you are familiar with JavaScript, then Node.js Express will be easier for you. You can find a link for the resources for all of them in the description below. You can start learning from there. An important thing regarding the learning phase is that you need to work on some projects along the part of learning. Like if you learn backend, then work at least 2-3 projects along the path while you are learning. Same goes for the front end part. If you are working on a front end, at least make 2 or 3 projects while you are learning to keep your knowledge intact and use it in a wiser manner. Coming to the front end part, front end is the most important part of a full stack development. As the name suggests, simply front end is related to coding, how the website shall interact, how the website shall look and behave to the user. So the basic thing, these are the building blocks of a website. After you are ready with the basic HTML, JavaScript and CSS, you should choose a framework, a front end framework like React.js, Vue.js or AngularJS. There are also other frameworks out there, but these three are the most popular ones and the most used ones. So each of them has their own pros and cons, as I said. To learn each of them, I suggest you to learn one of them first and try learning it in the depth and being proficient in one tech stack. Like if it is MER, and then be proficient with React. If it is MEV, and then be proficient with Vue. Similar way, if it is mean, then be proficient with Angular. So the best way to learn any front end framework is to go through its documentation. Each and every bit of the code that can be written in the framework language is mentioned in its documentation. You can find each and every types of query resolved there only. Pick up a project as you learn. Make at least 2 to 3 projects while you are learning. This will make you comfortable with the language, with the framework, and will also help you learn faster. There are also databases like SQL and non-SQL databases. Both of the systems serve different purposes, and it is essential for you to learn at least one of them to make a full stack development. Now coming to the resources part, we have linked the various YouTube channels and repository W3 Schools, freecodecamp.org and MDN Web Docs. All of these sites contain amazing amount of resources regarding each and every part, whether be it front end, whether be it back end, whether it be databases. You can learn incredible amounts of knowledge from all of these sites.
So, app dev is another great way to begin your development journey. As you can probably see around you, people spend a lot more time on their smartphones than they do on their PCs or laptops. And as apps are the best way to engage with any product or service on your mobile devices, app developers are paramount to any business and thus have a lot of demand in the professional sector. Now, before you pick up a technology and start developing mobile applications, there is one factor that you need to address, and that's platform dependency. It's also the first difference that we see between web development and app development. So, the thing is, modern web development has a single system of languages: HTML, CSS, and JavaScript. Now, there are tons of frameworks and libraries in JavaScript, but at the end of the day, you are still writing JavaScript. And you can be sure that the code that you write, the website that you develop, will work on every single platform as long as it has a web browser. It may not look good, it may look janky if you've not made it responsive, but it will still run nonetheless. Now, this does not hold true for app development. Since mobile apps work directly on top of the operating system, there are no translation layers like a web browser. What this means is that you have a different set of platform specific tools and technologies that are decided by the OS manufacturer that you need to use to develop an application for that particular OS. So, for example, Android requires the Android SDK that comes with Android Studio, and iOS requires Xcode. Similarly, the languages used for building these applications also differ. So, if you're building an Android application, you'll be using Java or Kotlin, and as well, if you're building an iOS application, you'll be using either Swift or Objective C. So essentially, unlike web development, where one code base will serve you across every single platform, app dev requires different code bases for the two major platforms. So with this, you may think that there has to be a better way, right? Something that lets us have our cake and eat it too. Well, fret not, because this is where cross-platform frameworks come to the rescue. So until now, we've been looking at native app development, right? That is, apps being built for a particular platform using that platform's native toolset. However, cross-platform frameworks abstract away the platform dependency and let us use one code base for both the devices. This does come at a cost though, as app performance will be noticeably worse than that of a native app, right? But if you think about it, the amount of time and money saved by not having to develop two different code bases as well as maintaining them is probably worth it. So let's talk about cross-platform development frameworks a bit more, and we'll start with the two most popular frameworks in this space. The first we'll be talking about is React Native. So React Native is basically what it sounds like. It's React brought to mobile apps. So you'll be writing the same JavaScript and JSX that you write for websites, except with native components instead of web components, right? So the components that you write will be specific to mobile applications instead of websites. So you can expect all the perks that come with it being a JavaScript based system, because you have the entire document, you have really good documentation, the entire JavaScript library ecosystem behind you. Many of the libraries that you use in React, like Redux, transfer over to React Native as well. So you have a lot of solutions for different problems, and since a lot of code is already out there to use for you, you don't need to spend as much time on developing the application. So that means really fast pace of development compared to like native app development, right? Uh, the second option is Flutter. Now, Flutter is a relatively new framework developed by Google, right? It uses Dart as its programming language of choice. Now, Dart, uh, many of you might not have heard about it because no other system uses Dart except Flutter. But because there's this, since Dart is only used for Flutter, there's this very tight integration between them, and Dart really seems suited to what Flutter, the design philosophy behind Flutter, right? What philosophy you use to develop your apps. Dart seems to be very well suited for it. Now, this is where uh, you run into the first issue with Flutter, right? Because it uses a new language, obviously that means that you have to pick up this new language. And since Dart is not used for anything else, it's not really transferable to other skills. Unlike React Native, where since you're still writing JavaScript, it's only a matter of like a few, it's not really a matter of a lot of time, right? It will take you very less time to move over to uh, normal React and start developing websites. But the reverse is also true. If you already know React, it's going to be really easy for you to pick up React Native and start developing mobile applications. So that's the first caveat. And the second is Flutter is still very new, right? Even though it's really popular and it's almost as popular as React Native, if you look at the charts, is by by now, by the 2021, is probably as popular as React Native is, right? So it's really popular, but popularity does not mean stability or maturity, right? The Dart and Flutter are still like really feel beta-esque, where the API keeps getting changed regularly, so you might find breaking changes between different releases, right? And the package ecosystem, even though it's growing at a really fast pace, so soon enough, like you will have as many good packages and useful packages as you have for the JavaScript ecosystem on React Native, you'll also have that on Flutter. But it's still beta-esque, right? It's not very mature. A lot of the packages, still have code that could easily break within a few releases. So this means that, the libraries have to be supported throughout major releases of the framework itself. So there's that issue, which leads to the general idea of broken applications every couple of releases. But it's still very popular. It has Google behind it, so it will become stable really quickly. The package ecosystem is getting really good, and Flutter, the way it works, right? The framework, the way it works, actually gives you better performance compared to React Native, right? So Flutter is the faster framework. So the experience of using an application built on Flutter is going to be better than smoother rather, than would be on React Native. And another thing is Flutter also integrates really well with Firebase. So if you want a serverless backend, you could go for Flutter and Firebase. In fact, the GLAG application was built top to down entirely on Flutter with Firebase as the backend. So there's that. Now, both of these frameworks are suitable for cross-platform development, and what I'd recommend is that you try both of them before choosing to dive deeper into a single. And one more thing, just remember, is you still need the Android SDK for Android applications and Xcode for building iOS to actually build the bundle that at the end of the day is used to install the applications on the physical device. So you'll still need those two, but yeah, the code base will almost be the same. And yeah, that's about it for what you need to know to begin your app dev journey. You'll find the links to all resources and documentation for Flutter React Native in the description below. And do comment which framework you choose to go with. I'll see you in the next section.
So now we'll be talking about projects. Projects have a very important part while learning a language. Building projects will help you to understand various efficient coding patterns, inner workings of the language, as well as best practices. You might not build something noteworthy at your first attempt, but don't let that stop you from exploring further, as coding skills need to be progressively built upon and it takes practice. You need to learn how to implement your knowledge by building apps and websites in which you apply different concepts that you have learned through various tutorials. A thing to note here is that do not add tutorial projects to your CVs, as it is good for learning purposes only and does not reflect your actual grasp of the concepts. Also, do not go about learning various things at once and stick to one framework at a time, at least long enough to build a certain level of expertise. While starting out a project, you will need to first design your concept of the app, what it does, and how you plan to achieve that. So, this is known as system design and is a very important aspect of software development, be it on any stack or on any platform. We will link certain resources you can go through to get an idea of how and what to build for your next project. You will also need to learn about version control systems, Git and GitHub, and also do regularly commit to your repositories, as GitHub tracks all your commits and puts them into a graph to show how active you have been, and it is always a plus to have a highly populated commit history while going to an interview for a developer role. Contributing to open source projects will also help you a lot in learning. They will not only help you in becoming a better developer overall, but have other benefits as well. So these projects have certain standards that all code must adhere to. So how this helps is it will help you in learning how to write good quality code, and in learning concepts specific to the language. Also, whenever you push your code to such repos, the feedback that you receive is also very vital, as they are experts associated with the project and have been working on the technology for a substantial amount of time. Searching for beginner friendly issues on GitHub is quite easy. Also, we will link a few sites to help you get started. So that's all that I wanted to talk for projects. So now get creative and start building your wonderful apps and websites. Now we'll be talking about research internships. Research internships are a great opportunity to work on real life projects under the guidance of a professor. You will need to explore the different fields and find out which one interests you the most, and then build your skills on the same. For such internships, a good CGPA helps too. A great time to start would be the break after the third or the fourth semester. There are generally two ways to apply. The first is through the official portal of the summer research programs offered by certain institutes. We will have a list of programs for undergraduates linked in the description. You will need to visit the application website where you will be provided with a list of projects, their mentors, and the required skill set for it. Go through them and then shortlist those which you think you have the necessary skill set for and are interested to work on, and then apply. To apply, you will need to provide the required personal details, and most importantly, you will need to attach your CV, a statement of purpose, which is basically what your research interests are and what you have done so far in that field. You will need to keep an eye out for important dates of these programs as they may vary from institute to institute, but start searching for summer internships early on, say during the months of February or March. To get an idea of what topics these range from, you can look at past projects on these websites. The second method is by mailing a professor of a university. For mailing professors, you will need to go through the faculty list on the university's website and go through the professor's research interests. Again, shortlist those professors whose research interests align with yours and mail them. While you should aim high and mail foreign universities too, they might not be very willing to take up foreign students with no experience. Nonetheless, getting an internship at an Indian institute, IITs or triple IITs, is way easier and might give you the necessary experience and hopefully a letter of recommendation needed to apply to said foreign universities. These letter of recommendations will help you when you apply to a university for higher education, whether Indian or foreign. So that is all for research internships. Start building your resume as soon as you can so that you don't miss out on these wonderful opportunities when the time comes.
Let's talk about cybersecurity. Cybersecurity is one of those fields which will continually see growth in the future. Considering that we are moving towards a more connected future via the internet, it is of paramount importance that we have a good cybersecurity base for any industry. Thus, moving forward, although this field has exponential growth potentials, you will have to make sure that you are on top of the game and know your basics around various prerequisites, be it programming, Linux, or anything else. You have to be continually updated about the new vulnerabilities and how they are worked with, and you have to build your skills on a lot of platforms simultaneously. So we will be looking into a few prerequisites for cybersecurity. Firstly, Linux. As the operating system of choice for the web, learning Linux is a primary source of knowledge in cybersecurity. You need to know your way around a Linux terminal, or else you wouldn't be able to go far over here. Most of the systems which you will try to protect or exploit are using Linux on the web. Thus, not knowing your way around them will not help you get anywhere. Apart from that, most of the cybersecurity tools or penetration testing software are more easily accessible on Linux than on any other platform. Thus, help you get started, you could get started with any distro of your choice and install the tools as per your need. Or you could start with an operating system like Kali Linux, which is geared towards penetration testing, and then work your way up from there and get to know what you want to use and what you don't want to. Apart from this, even though you might know how to use tools, having no programming knowledge along with it is a big liability. Like if you do not know how to write basic code or to make sure that you will not be able to go far either, because after a certain point of time tools will be only as good as you can use them. So you might have to write various scripts to get what you want and to make sure that you do your job properly. Thus, getting started with a basic programming language like C, C++, or Python is essential. Apart from this, we have the computer networking basics. Computer or networking, like operating system, the basics of the operating system, the basics of the applications, how applications communicate with one another, how networking works, what is an internal network, what is the wide area network, how you can use these things. All of this sounds like a blur, right? But that is the thing. You need to know the basics, considering you will be looking for very minute vulnerabilities present in the network or in the operating systems or on the applications which you are trying to exploit or protect against. It is of paramount importance that you know them very minutely, or else you wouldn't be able to find any vulnerabilities in the first. And finally, the internet will always be the greatest tool which you have at your disposal in getting good at cybersecurity. Most of us have learned through the internet and Googled our way trying to find out new data and trying to learn new things to get good at cybersecurity. So, apart from the prerequisites and the knowledge, right, where are the places where you can apply your knowledge? These are the platforms. You could try hack me, hack the box, or root me, and you will be given various challenges to conquer on the basis of your cybersecurity skills. There are other certifications courses as well, but learning through these platforms, they also help you get good over time, and they have guides and various other things where you can start. Moving on. So as a second year student now, what should you do in this vacation? If you want to pursue cybersecurity, participate in CTFs. Head over to CTF time and log the dates of whenever a major CTF is coming up and participate in them. Participate, win prizes, get better. But more than that, after the CTF is over, usually the organizers have a blog post wherein they describe all the problems present in the CTF in detail and help you to gain knowledge from there. So make sure that you just don't participate, but learn from the CTFs as well after the problems are over and you weren't able to solve any of them. You could play war games like Over the Wire, or you could also go for a more dedicated approach via some minuscule form of mentorship to various YouTubers like John Hammond, Cyber Mentor, or Live Overflow. They will help you with the basics and they will make sure that you are on some level before you begin participating in CTFs by yourself. But more than that, you have to be aware of the new vulnerabilities which are happening in the world around you. If you're not aware, then you will not be a good cybersecurity expert in the future. Thus, hoping that you are able to make the most out of these and head over to these resources and start your cybersecurity journey. Well, going through this video, what we wanted to do was provide you the skills and the resources so that you could start on whatever thing you are interested in, right? And it is okay to not know what you want to do. And it is okay if you find a lot of these things interesting. Now is the time to experiment and find out what you want to do and choose what you want to do. At the end of the day, you will have to choose between a few of these things, right? If someone is more research oriented, they would go for the research mentor and research mentorships. If someone wants a placement, then they will go for their TSA preparation. If someone wants to get good at competitive programming and be very good at it, then they will go for that, right? And if someone wants to develop or someone wants to go for cybersecurity, then they'll go for that. However, if you are interested in a lot or all of these, we suggest finding your way first and then choosing at most one or two of these domains wherein which you want to master. Or else later you will face a lot of issues trying to balance everything. It is always possible, but trying to do too many things at once will only make you feel most. And apart from all of this, stay safe during your vacations and choose and learn as you want. Thank you. This has been a presentation from the GNU Linux Users Group and IT Data.